इकडे ये, तू पण बसून ऐकू शकतो.
Chalo, let us begin. Last lecture we have seen Pythagoras theorem, Heron's formula, and okay, today okay, do we mean by perpendicular bisector? Suppose there is a line segment AB. We can draw infinitely many perpendicular lines to segment AB. So perpendicular lines infinitely many. If we want to draw bisectors, then the line must make two equal parts of segment AB. Therefore, again we can draw infinitely many bisectors passing through midpoint. All must pass through midpoint, but they are infinitely many. Bisecting lines again infinitely many. But when it comes to doing both the tasks together, it is a unique. So we will have a unique line which will be perpendicular and bisect. तेच बोर्ड चालू केलास की नाही मला कळलं नाही म्हणून फोन करत होतो. ठीक आहे ओके. Perpendicular and bisector. Only one. Unique line. Therefore, it is very important line in geometry. It is not only perpendicular, but also it bisects the segment. It is important that you have a segment which gets bisected. We cannot bisect the line. If line is there, then we cannot bisect it. Because line, we cannot draw infinite, but actually when we put these arrows, it means that line is not stopping. It is continuously on. And perpendicular bisector is a line. So perpendicular bisector is of segment. The ray, not the line. Understood? So if I say a point is on perpendicular bisector, I mean that there is a line which is perpendicular bisector of a segment, and the point is on that line. So given point P is on perpendicular bisector of segment AB, To prove P is equidistant from A and B, right? So we draw AB segment, we draw perpendicular bisector, straight line. This is perpendicular point M and it is bisector. So suppose we take a point P, unperpendicular bisector, then we are supposed to show that its distance from A and B is equal. That means if we join these, that is to prove that PA equals PB. Okay. Now I expect you to write six-liner proof, congruency proof. Three reasons, then congruency of triangles, then deduction. Total five and consideration to start with. What correspondence you are going to assume. So it is a good practice to write the congruency proof here, and it is very simple. So I am interested in knowing the test of congruence. So maybe if you want to show me something, you should first complete the six-liner proof, and then you can show me the word why those two triangles are congruent, the name of the test, and that is all. So it is easy question. Solve.
Sir, by SAS, the triangles APM and BPM are congruent.
You are supposed to write and show it to me. Sixth lecture today.
Is this correct?
You should show me the name of the test. That's all. Otherwise, it is going to be difficult to read the proof.
SAS test.
मॅडम जोरात बोलायचं नाहीये उत्तर. तेवढ्यासाठी मी इन्स्ट्रक्शन दिले होते की व्हाईट बोर्ड वापरा म्हणून. एकाने उत्तर सांगितलं की बाकीचे विचार करायचं बंद करतात.
सर दिसतंय माझं?
नाही, ज्यांचं दिसतंय त्यांना मी सांगेन नाही दिसत आहे मला, कोणाचंच नाही दिसत. सगळा प्रूफ दिसतंय अख्खा. हा, अर्पिता मॅडम करेक्ट. Sachin, correct. You have to learn how to show your answer. Correct. Shriya Joshi madam, correct. बाकीचे दाखवत आहेत पण मला दिसत नाही. हा, गौरांग करेक्ट.
सर
तेज करेक्ट.
हॅलो सर.
येस.
सर बाकीचे लिहितात तोपर्यंत एक प्रश्न विचारू का?
हो विचारा.
ते एक असं आहे की प्रत्येक सेगमेंटचा मिड पॉइंट युनिक असतो. हे युक्लिड्स पॉस्च्युलेटने कसं प्रूव्ह करायचं?
त्याच्यासाठी 10-12 युक्लिडची पहिली 10-12 पॉस्ट्युलेट्सचा अभ्यास करायला पाहिजे पहिला.
हा म्हणजे मला ना ते प्रूव्ह कसं करायचं ते लक्षात नाही आलं. युक्लिड्स पॉस्च्युलेटने की ते युनिक आहे असं.
हा तेच ना, पण म्हणजे कसं असं मध्येच नाही करता येणार ना, पहिल्यापासून पॉस्ट्युलेट्स करायला हवी मग ते येतं.
चालेल सर मी दाखवते.
काय दाखवताय?
हे प्रूफ
आन्सर ना. हा बघतोय मी. ज्यांचं ते कोटेश्वर सर करेक्ट.
इज इट करेक्ट?
If I can see SAS, I will say correct. Otherwise, it is not visible. Ha, Shubhangi madam, yes. Okay. This is by SAS. Okay, and need to be written correctly with correspondence PMA, PMB, 90 and AM equal to BM is already available with us. The only thing that you need to add, third one is PM congruent to PM, and therefore by SAS. So this is very simple. By SAS, we deduce that any point, P was any general point on perpendicular bisector, and if we take any point on perpendicular bisector, we get it equidistant from A and B. So we call this theorem. P is a point on perpendicular bisector of AB, then it is equidistant from A and B. This is the statement of theorem. For our convenience, let us say that this is perpendicular bisector theorem number 1. Okay, so now let me write down perpendicular bisector theorem number 2, which is converse of this. If any point P is equidistant from endpoints of segment AB, then P lies on perpendicular bisector of segment AB. Okay, let me try to give you the diagram also before you start writing the proof. Now I have AB and I have a point P which is supposed to be equidistant from A and B. Okay, this is the diagram. Point P is equidistant from A and B is given to you. Now you are supposed to show that P lies on perpendicular bisector of AB.
पहिलं असं केलं काय हो ठीक आहे सांगा
बरोबर
हो ना
हो
पहिलं आताही करतो
हो फक्त ह्या प्रत्येकाचं पण मुलांना आम्ही रिझन लिहायला लावतो. Rudresh sir, SSA is not the test of congruence. Now, this is little difficult because
Sir,
yes,
we have to do some construction.
hmm,
As we
yeah,
take the midpoint of AB, we can join the point P and midpoint of AB. Suppose M,
hmm.
and then
Okay, enough. You have disclosed. Let us do that and give it to all. So now the problem why you are not able to do it, majority of you, is because of this. We are simultaneously supposed to prove it is perpendicular and also bisector. So we are having two requirements of the straight line that we wish to eventually prove. So we can take one by construction because anyway we don't have two triangles. So we can take one. So suppose we take a straight line which is bisector. So we draw a midpoint M. By construction, M is a midpoint, so AM is equal to BM and then join a PM. We can do that. And now PM is bisector already by construction. We are supposed to show that PM is perpendicular also. This is one approach. Second approach could be you draw perpendicular from P on M on AB, let them intersect at M, then we have drawn perpendicular, we have to show that it bisects. Then the theorem will be complete. So if M is a midpoint, then consider proof. PAM with PBM. Statement 1. AM congruent with BM by construction. Two, PM congruent with PM self-congruent. And 3, PA congruent with PB given. This implies, therefore, for triangle PAM is congruent with triangle PBM by SSS. This implies for you major angle PMA equals major angle PMB. Note major angle PMA plus major angle PMB is equal to 180. Angles forming linear pair. Therefore, major angle PMA, which is equal to PMB. So 2 times major angle PMA is equal to 2 times major angle PMB is equal to 180. Therefore, major angle PMA equals major angle PMB equals 90. Hence, PM is perpendicular to AB. Theorem proved. So this is complete correct proof if you assume midpoint by construction. Another way could be draw perpendicular. And there could be few more ways because we have proved isosceles triangle property, so we can assume that angle at A and angle at B are equal. So more than one ways of doing it. This is the method where we are using SSS test.
ASA टेस्ट नुसार कॉन्ग्रुएंट होतील ना
हा
ASA टेस्ट नुसार
हा अनेक प्रकारे होऊ शकतं. येस
आयसोस्केल ट्रायंगल्स दाखवल्यानंतर बेस अँगल्स आर कॉन्ग्रुएंट
बरोबर आहे. करेक्ट.
आणि म्हणून अँगल बायसेक्टर ड्रॉ केल्यानंतर आपण दाखवू शकतो
ASA करेक्ट.
ASA टेस्ट.
येस दाखवू शकतो. Okay, so we call this as converse of PB1 and hence PB2. So PB1 is if any point lies on perpendicular bisector, it is equidistant from the endpoints of the segment. And PB2 is if any point is equidistant from endpoints of segment, it lies on perpendicular bisector. Okay, good. If we are done with this, then we have to search application of these theorems. First application is
Sir, just a minute, sir.
yes, yes. Oh,
Can you just bring it back?
sure, yes.
Sir, I was lost in between. Maybe a two major PMA is equal to 2 major angle PMB. From where it came?
Because major angle PMA plus major angle PMB is equal to 180. They are in linear, and both of them are equal. By
Okay, the fifth, yeah. With reference to the fifth point, it came.
yes, we have proved that they are equal. We have proved that they are equal, but we have not proved that they are 90. They could be less than 90. They could be more than 90. Therefore, we have to add these 3-4 steps in this proof.
Got it, sir. Thank you.
Good.
सर
Yes. Yes.
तर हा जो पी पॉइंट आहे, हा पी पॉइंट समजा एम वर ओव्हरलॅप झाला तर तो
P point.
अँगल बायसेक्टरला कसा प्रूव्ह करता येईल?
P point काय?
पी पॉइंट समजा खाली आणत आणत एम वर ओव्हरलॅप झालेला आहे, तर अशा कंडिशनला तो कसा प्रूव्ह करता येईल की तो अँगल बायसेक्टर वर आहे म्हणून?
अँगल बायसेक्टर कुठे प्रूव्ह करतो आपण?
अँगल नाही,
परपेंडिक्युलर बायसेक्टर.
परपेंडिक्युलर बायसेक्टरला आहे, हे कसं प्रूव्ह करता येईल? पी जो आहे समजा खाली खाली आणत गेलो
हा.
तर दोन ट्रँगल सापडणारच नाही आपल्याला.
हा, पण मग ती सोपी केस आहे ना.
सोपी आहे का?
हा, कारण जर तो पी आणि एम इक्वल असतील तर पी आणि एम इक्वल असतील तर एम इज अ बायसेक्टर, पी इज अ बायसेक्टर ऑफ ए बी, अँड P and M coincide, then we can draw infinitely many lines. Yeah, but then we are supposed to show that it lies on. Yeah, so fair enough. So this is P. This is P oblique M. It is a midpoint. So P lies on perpendicular bisector. If you happen to draw perpendicular bisector of segment AB, and if it is a midpoint, and that point, if suppose we have chosen as our P, then it is a very easy case. We need not have to do anything and say that yes, P lies on perpendicular bisector. And the most difficult case is to have point P other than M. Point coincident with M is very lucky case and very easy.
हा सर, बरोबर आहे.
Ah,
येस.
yes.
Huh.
Okay. So let me keep this on board and create one application so that you can start thinking. Application is all three perpendicular bisectors of sides of triangle are concurrent. Okay, this is the third theorem that we are going to prove, out of which you may not know the meaning of this concurrent. I mean, if more than two lines pass through the same point, we call them as concurrent lines. They have a point in common, looking like this. 2 points not parallel will pass through a common point, intersecting point. So nothing great about it. But if we happen to have the third line also passing through the same point of intersection, then these 3 lines are called concurrent lines. So more than 2 it must have. Right now I have drawn 5 lines, 4 lines, 5 lines, which are concurrent. So there are infinitely many lines which pass through that particular point, concurrent. But surprisingly, no matter how you draw triangle, if you happen to draw their perpendicular bisectors of the sides, they are going to be concurrent. So Let me draw a triangle ABC. And if I draw perpendicular bisector of AB, if I draw perpendicular bisector of BC, then of course they will intersect. But then through that intersection, the theorem says through that intersection, the third side perpendicular bisector also will pass, which is amazing because we have drawn random triangle and we are drawing three different perpendicular bisectors, but every time they will pass through a common point. So I wait for 5 minutes, write down the proof. It is going to be 1, 2, 3, 4, 5-liner proof.
Can you please repeat what we have to prove?
We have to prove that if we draw all the three perpendicular bisectors of the sides of triangle ABBCCA, then we have to prove that they pass through a common point. The point of intersection of all the three perpendicular bisectors will be the same. Chalo, let us discuss. Because this is first time you are doing it is difficult. I will give you one more problem like this. Next time you will be able to do it. Now, because I want to show that three lines are passing through a common point, I mean, it is not a congruency problem. So what would be my strategy? Two non-parallel lines will always intersect. So we start with, say, perpendicular bisector of AB. We draw perpendicular bisector of AB. Perpendicular and bisector. We draw perpendicular bisector of AC because two lines are always going to intersect. So perpendicular bisector of AC. This is also 90 and this is equal. So let us give name to this point P. Okay. So let me start writing the proof simultaneously. Let U, line U, be perpendicular bisector of segment AB. Let line V be perpendicular bisector of segment AC. They meet at P. Correct? Let us say this is statement 1, statement 2. They meet at P. Statement 3. Now,
P lies on perpendicular bisector of AB. So AB
तुम्ही आधी लिहून मला का नाही दाखवलं?
मला सर वही दाखवता येत नाहीये तुम्हाला.
अच्छा, ठीक आहे. पण आता डिस्क्लोज नका करू, मला माझ्या पद्धतीने शिकवू द्या.
ओके ओके सर, सॉरी.
P implies P lies on PB of AB. बरोबर आहे? They meet at P and both of them are intersection of this. So I am again writing P lies on the perpendicular bisector of segment AB. But this was our condition of PB1. This implies by PB1, P is equidistant from A comma B, which is PA is equal to PB. Right? So we show that in our diagram, PA and PB are supposed to be equal because of perpendicular bisector theorem, which we have proved just now. Good. Three also implies P lies on perpendicular bisector of AC.
AC.
Therefore, by PB1, P is equidistant from A comma C.
Sir, what is PB1?
Okay, PB1 is this. This PB1. The first theorem that we have done today.
Yes, got it.
And just keep in mind that this is a PB2, the converse of that. Okay, so P is equidistant from A and C, which means PA is equal to PC. ठीक आहे, 3 पर्यंत झाले. So this is 4. Statement 5. Okay. So this is halfway done. Now we are supposed to show concurrency. That means the third line also passes through point P. So can you complete now? Two more steps, two more lines, and the proof is complete. अमित सर ब्लर आहे, सगळं दिसत नाहीये.
ट्राय करतो.
Sir, will this be accepted?
Yes. Correct. So 4 and 5 put together imply PA is equal to PB, PA is equal to PC. So 4 and 5 together will imply PB equals PC. Okay, after we have written this PA is equal to PC, we must have shown here that yes, this is also equal to PA. So the PA equal PB by statement 4, PA equals PC by statement 5. So we decorate our figure accordingly and now realize that PB equals PC. Therefore, by PB2, perpendicular bisector theorem number 2, P lies on perpendicular bisector of BC. Theorem proved. Hence, all 3 perpendicular bisectors are concurrent. समजलंय? So the moment we have 2 theorems with us, 1 theorem and its converse, its application is also there, and it is very, very important application. If you look at the diagram, P point P is equidistant from A, B, and C, all 3 points, all the 3 vertices. So if we take a compass, put the steel point on P and take radius equal to PA or PB or PC, then P will become the center of the circle and circle will pass through all the 3 vertices. So this is circumcircle. And this P is circumcenter. it is going to be a unique point in the plane, which is equidistant from all the three vertices. And there will be a circle passing through these 3 points, 3 vertices. Its center is going to be circumcenter. Very important. Concurrency has given us this circle, which is triangle is inscribed in the circle. Circle circumscribes the triangle. ठीक है? Okay. Clear?
हो सर, तुम्ही ते
Sir, can we
अप्लिकेशन हा
draw the
शब्द कसा
encircle
वापरला जातो?
also?
एक मिनिट हा, वन बाय वन. हा,
Sir, can we draw the encircle also?
circumcircle is the circle with this concurrency point as a center, and radius, all these 3 segments are equal now. त्याला circumradius म्हणतात. So PA, PB and PC, this is circumradius. So if we put still point at P and take radius equal to PA and draw circle, then that circle will pass through all the 3 vertices, B and C. Yes, question?
Sir, I'm asking you about the we can draw the circumcenter with the help of this. Can we draw the encircle also?
नाही,
नाही करता येत का?
नाही.
Okay.
We can draw circumcircle because we have found out the point which is point in the plane of triangle, that is the unique point, only one point, which is equidistant from all the 3 vertices. And therefore, using that as a radius and that as a center, we can draw circumcircle. Okay, any other question?
तुम्ही अप्लिकेशन हा शब्द वापरला तो कसं, म्हणजे कशासाठी
Application
वापरला?
of PB1 and PB2. Perpendicular bisector theorem 1 and its converse are used
अच्छा,
here to prove that the concurrency of 3 lines. So application of PB1 and PB2 is concurrency.
ओके ओके.
Sure, good. Now. Negative means?
Between P and 1 point, there is another point P dash. I tried out, I think.
Difficult. या स्टेजला difficult आहे. Okay. Now let us do little bit of work with respect to angle. Before that, suppose I have a line and I have a point not on line. Point P is not on line L. And I want to define the distance of P from L. This is the task given to us. So what we can do is, we can select any route to reach L. There will be infinitely many routes to reach L. We can go like this and reach L. So which amongst these we should define? Definitions are man-made definitions. Therefore, we are free to define anything that we want. So we want to discuss we want to define the distance between point and line. Distance between 2 points is defined in the postulate. The postulate is two distinct points in space, there corresponds a real number. This is a distance postulate. What it says is, if you take any 2 points in space, there corresponds a real number to it. Now, how do we find out what real number? So this is distance postulate. Then it says, you are free to create a ruler. Ruler means you draw a straight line, take any one point as 0, decide unit of measure, call it as 1, Then decide equal distances, you can call it as 3, other side -1, -2. So you are allowed to convert the straight line, which is a geometric object, into a ruler, which we will help to measure the distances. This is ruler postulate. You can create a ruler postulate. Okay. And then ruler placement postulate. You can take the ruler wherever you have made, take it to the point where you want to measure the distance. So if I want to find out the unique real number associated with these 2 points, P1, P2, then ruler placement postulate says that take this ruler, that means our scale, which is a different object, we can move wherever we want, put it, take the scalar, put it in such a way that this point is 0, this, and maybe 1, 2, 3, 4, 5, and find out what this point is. So in this case, suppose I get 5.3. Then 5.3 is a real number which is associated to these 2 points, that is by distance postulate, and no questions asked, that is distance between 2 points. Very easy. Straight, use scale or nothing. Distance postulate says to 2 distinct points there corresponds a real number. Ruler postulate says you can create a ruler, and ruler placement postulate says that you can take the created ruler and measure the distance between the 2 points. The procedure is explained in the postulate, and that is the real number associated to 2 points. But then the situation here is different. Here there were 2 points. Here there is only 1 point. And therefore, we have to define what do we mean by distance between point and line, and what is going to be the obvious definition. I mean, if I define this as a distance, then there will be one more segment exactly other side. So which one? Foot of perpendicular or foot distance from this point should I measure, or this point should I measure? And there will be more than one ways of getting the same distance. So it is going to be confusing, and hence they have decided to drop perpendicular, and then this is going to be the shortest distance, and it is going to be the unique line. It is a unique line segment which you will get. No other line segment will have distance equal to PM. PM is going to be the shortest distance. Okay, of course, if you draw the curve line, it is going to be bigger. So why will PM be the shortest is a question. Suppose PM is not short. How can we prove that PM must be shortest? And the proof is very simple. Let n be any other point and join Pn. Because PM, we got M by putting perpendicular. This is right angle triangle. And right angle triangle hypotenuse is greater than any of the 2 sides. So any other distance using straight line that you want to say that it is minimum, it is not going to be. The only minimum distance is going to be the perpendicular distance. And therefore, when I say distance of a point from a line, I mean I am supposed to put perpendicular and measure that segment, measure the distance between point and foot of perpendicular. That is the distance I am supposed to measure. So this clarification is required because we are going to use distance of a point from a line or distance of a point from ray. Okay, so I have an angle with me now, angle ABC, and we can draw bisector. Okay, can we draw bisector of an angle? The ray which will bisect the given angle in 2 equal parts. Can we draw? Any school teacher knowing the procedure, how to bisect the angle?
Sir, we need to take the one arc on BA.
One arc on BA,
Same distance we need to take and draw one arc on BC.
one arc on BC.
Then more than half distance, and from that inside the angle ABC.
More than half of what?
Any distance you can take on the compass, and from the whatever arc we draw
All
from
these
that
points, M and
Yeah.
N. Then
M and N, we take a one more arc inside the ABC.
I can take any distance in compass.
Yes, you can take any distance.
Okay.
From M point, you
I've taken
draw
one distance and draw one arc.
Yes,
No, sir.
inside the ABC.
Another also.
Inside the
Yes,
No, sir.
I have drawn two arcs from M and N.
Yes, and take a on M point, you
Yeah.
draw any arc inside the ABC.
Yeah, I have drawn not only arc, I have drawn the entire circle.
No, sir.
Not
Measure
there.
measure
मला म्हणायचंय
MN.
सर की M वर ठेवून एक आर्क मध्ये एबीसी अँगलच्या मध्ये काढायचा आहे.
मध्ये काढायचंय का? बरं, ठीक आहे.
कंपास एम वर ठेवायचा आहे.
हा, हे बघा
आणि
ठेवला.
तिथून-
हा बघा, हा कंपास आहे. ठेवला M वर आणि एक आर्क काढला मध्ये. हा.
Not like this. You should take
Sir,
the more
MN
than half
compass-
distance.
Sir,
More than
compass
half, I
मध्ये
am not able to understand. More than
MN.
PM च्या more than half.
where is P?
sir
BM,
uh,
BM.
PM च्या more than half.
Yeah.
नाही सर MN मेजर करा सर. अप्रॉक्सिमेट MN मेजर करायचं, थोडंसं वाढवायचं आणि मग काढायचं.
थोडंसं
Compass
वाढवलं
मध्ये-
म्हणजे होईल का? बरं.
हा, M आणि N हे दोन पॉइंट घ्यायचे कंपास
अच्छा, एक
मध्ये.
इकडे काढायचा, एक
थोडंसं
इकडे काढायचा असं.
Yes,
Ah.
right. And
Ah.
then you connect it with the B.
Understand why I was drawing smaller arcs?
Yeah.
My compass is very small. I cannot draw big arc. So, but in that case, I will not get an angle bisector. So, okay, now I have got another compass and I have got this point. Okay, so what should I do now?
In
Join
B
that point with
to
B.
intersecting point.
Okay.
At intersecting point, we can say P and
Okay.
join this P to
So
B.
is this going to be angle bisector?
Yeah. ABP
What
and
it is supposed to-
BPC.
It is supposed to bisect the angle, huh? How do we know that it is an angle bisector? This is a procedure, okay, correct. There could be another procedure by which we will get another ray. Will we call that as angle bisector also? Nice, something wrong or correct? We have not measured angle anywhere. I mean, suppose this angle is 38 degree here. So will we get 19 here? Exactly 19 will we get?
Yes, we will get.
Why? Why will we get exactly 19? I mean, this procedure was there in 7th standard when I was in 7th standard. Maybe it was there in 7th standard when my father was also in 7th standard. That is correct. And we have completed our education using this kind of procedure. But then, I mean, it is some algorithm by which you get one ray. May not be the bisector, some compromise somewhere.
Subodhji.
Yes, Koteshwar sir, wait for a minute, for a couple of minutes.
Okay.
So now our job is, suppose somebody challenges us that this is not bisector, our job is to prove that it is angle bisector. Right? So you will be able to do it. Just you need to put some more energy in it. That's all.
We have to
It is
construct
obvious,
some
I mean,
more.
it is not there in
more
any
lines.
of the books. It is obvious and it is not there in any of the books. We have to put our energy into it so that we will be able to show that yes, this x is equal to x. We have done it several times in last 3-4 lectures. So can we do it? And therefore this procedure, the one who has designed this procedure has that in mind. But unfortunately, Generations do not know why it's this angle bisector, because he designed it and then we are using it as a trick or a procedure without knowing why it works. So it is very simple. हाँ सर, कोटेश्वर सर बताइए.
Sir, I think it is okay because let's say if I join N and P and
Yes.
M and P by SAS,
By SSS.
SSS, triple S, the two triangles are congruent.
Congruent, because we have constructed them.
We have constructed
Is equal to
forcefully.
Bn by construction.
Yeah.
P is equal to NP by construction, and BP is a common side.
Common side.
Common side. So SSS, these two triangles are congruent, and therefore corresponding angles of congruent triangle, we are bound to get this as angle bisector. That is the reason why it is going to work.
We can as well put the perpendicular from P on BA and BC, and that way as well we can prove, sir.
Wait, let us see. You want me to draw one more figure? Angle. Now, ABC is the angle, and we want to draw angle bisector. Tell me, what is the procedure? Okay, the procedure is same. You want to say that from P you draw perpendicular for proof.
Yes.
Okay, so I draw perpendicular from P, call this as D and E.
Yes.
Then what?
Then angle S then by one condition, the two triangles are
No, we require three conditions for two triangles to be congruent. We require three conditions.
No, sir, this may not be right.
No, this is not going. It is. I mean, other than this SSS, nothing is going to work. Okay, so using this, let us do. No, you don't have any additional information about that P. Okay, now let us write. Given P lies on angle bisector of angle ABC, then to prove that P is equidistant from BA, ray BA and ray BC. Okay, this is going to be simple for you now. This is A, B, C. And we have already drawn perpendicular bisector, angle bisector, and taken point P on it. Then the theorem says if you draw perpendiculars, PM, PN, then to show that PM equals. Now you can complete. It is given that this is angle bisector. Now you can complete very easily. Show me the test of congruence. Show me the test of congruence.
तर त्या सरांनी आता जसं सांगितलं तसंच इथे आपण करू शकतो ना सर, राईट अँगलनी करू शकतो ना आपण? राईट अँगल ट्रायंगलची जी टेस्ट आहे कॉन्ग्रुएन्सीची ती घेऊ शकतो का आपण?
नाही, आपल्याला हे दोन माहिती नाहीये तिथे. आता मी तिथे येतोय, इथे हा अँगल बायसेक्टरवर आहे पॉइंट पी, म्हणजे मी हे दोन इक्वल दिलेत माझ्याकडनं तुम्हाला.
नाही, आपल्याला हे दोन इक्वल आहेत हे प्रूव्ह करायचे. त्याच्यासाठी आपण काय केलं की पीएन आणि पीएम हा इक्विडिस्टन्स आहे हे दाखवलं, आणि राईट अँगल आहे. पीबी हा हायपोटेनियस आहे. मग राईट अँगल
पीएम आणि पीएन इक्विडिस्टंट कसं दाखवणार?
ओके, प्रूव्ह करायचंय ना ते आपल्याला. पीएन आणि पीएम हे इक्विडिस्टन्स आहे हे प्रूव्ह करायचंय का?
या थेरम मध्ये.
ओके, आणि नाही, प्रिव्हियस मध्ये म्हणतीये सर मी. प्रिव्हियस साठी आपण
तुम्हाला हा पीडी आणि पीई इक्वल आहे ते माहिती नाहीये.
ओके ओके. आणि आपण कन्सिडर पण नाही करू शकत का कन्स्ट्रक्शननी?
नाही, मग त्या केसमध्ये असं पण आपण करू शकतो ना, की आपल्याकडे एक अँगल आहे आणि हा पॉइंट, दिस पॉइंट पी इज ऑन अँगल बायसेक्टर असं मी म्हटलं, तर कन्सिडर पीएम इज इक्वल टू पीएन असं म्हणून पण ते होईल ना.
ओके ओके ओके
दॅट पॉइंट नीड नॉट बी ऑन अँगल बायसेक्टर.
ओके. नाही, पण राईट अँगल ट्रायंगलची जेव्हा टेस्ट असते सर, त्याच्यामध्ये एक अँगल 90 असतो आणि 90च्या अपोजिट जो हायपोटेनियस आहे तो जर कॉमन असेल तरीही आपल्याला अजून एक साइड दाखवावीच लागते का सर, कॉन्करंट आहे ती टेस्ट दाखवण्यासाठी?
हो, कारण कॉन्ग्रुएन्सीसाठी मिनिमम 3 गोष्टी लागतातच.
नाही, बाकी गोष्टींसाठी ठीक आहे, पण राईट अँगल ट्रायंगल जर असेल तर तेव्हा दोनच गोष्टी लागतात ना, एक राईट अँगल अँड वन साइड.
नाही,
हायपोटेनियस पण पाहिजेच का?
RHS.
ओके, RHS.
आर म्हणजे राईट अँगल, एच म्हणजे हायपोटेन्युअस, एस म्हणजे साइड.
वन मोर साइड. ओके ओके, थँक्यू सर.
प्रीती मॅडम करेक्ट आहे, मधुरा मॅडम करेक्ट आहे, गुड. आता मी जरा माझी विंडो मोठी केली आहे, त्यामुळे 2 स्क्रीन्स मला बघायला लागतात. सो इफ यू आर शोईंग, यू टेल मी दॅट यू आर शोईंग, आय कॅन चेक क्विकली. हॅलो, हे मधली नाहीये, 2 अँगलच्या मधली साईड नाहीये अवेलेबल. हे इन्क्लुडेड साईड असेल तर ते वापरायचंय. 2 अँगलच्या मध्ये जर साईड इन्क्लूड होत असेल तर ही टेस्ट आहे. हा, कोण कॉमन आहे, पण ती मध्ये पाहिजे ना. 2 जे अँगल तुम्हाला माहिती आहेत त्याच्यामध्ये ती साईड असेल तर. हा, मग ते करून मग ते केलं का तुम्ही? हा, मग ठीक आहे, मग बरोबर आहे. मला वाटलं हेच 2 अँगल वापरून आहे. पण त्याच्यासाठी आपण अजून एक तयार करून ठेवली आहे टेस्ट, हे काम करायला लागू नये एक्स्ट्रा म्हणून. Okay, so in this diagram you can see one angle is equal 90-90. Given that these angles are also equal, and we want one side which is BP is equal to BP. So angle, side. So these two triangles are going to be congruent by SAA. Side, angle. सगळ्यांच्या लक्षात येत आहे? So we don't stop here, we move on. These two triangles easy to prove. And of course, if you do little bit of work and prove that this angle is also equal to this, because of sum total is 180, you can use ASA also. But SAA is made for this. Okay, so let us flip these two. So we call this as AB1, angle bisector theorem number 1. This is AB1. What should be the converse? Just flip these two. Converse is going to be given P is equidistant from ray BA and ray BC is to show that P lies on angle bisector of ABC. Right? So let me draw and give it to you. And if P is equidistant from BA and BC, it is given. Now here the definition is important. When I say P is equidistant from ray BA, it is perpendicular and equal. It is perpendicular and equal. Hence you show that if we join BP, then it is going to be angle bisector. P is going to lie on angle bisector. To show that, in other words, PBM, measure angle PBM equals measure angle PBN. Yes, show me the test. And you are good in congruency now. If your tests are correct, then you are good in congruency. This is very important in full geometry. Correct, Preeti madam? Yes, Madhura madam, correct.
सर
हा, अजून आता जरा कॅमेऱ्याच्या अजून जवळ आणा वही. अजून अजून हा, करेक्ट विशाली मॅडम, करेक्ट. अरे पटणे मॅडम, तुम्ही वही जवळ आणलीत की त्याच्यावर अंधार पडतोय. हा, दॅट इज बेटर. नाही, नॉट करेक्ट. ओके, सीमा मॅडम येऊ द्या
हा,
जवळ. वही तुम्ही परपेंडिक्युलर केली, दिसणार नाही मला. हिरवा गोल आणि कॅमेऱ्याच्या जवळ घ्या. 90
दिसतंय सर.
डिग्री 90 डिग्री मध्ये क्लॉकवाईज फिरवा वही. सीमा मॅडम, वही फिरवा. हा, आता जवळ येऊ द्या. हा, आता तुमच्या राईट साईडला घ्या वही थोडी. अजून राईट. अरे, कोणते टेस्टचं नाव तुम्ही काहीतरी वेगळंच लिहिलंय. आपल्याकडे 5 टेस्ट आहे.
हायपोटेनियस साइड टेस्ट लिहिले.
अच्छा, ठीक आहे. RHS बरोबर.
बरोबर आहे का?
मॅडम करेक्ट. सचिन सर करेक्ट.
थँक्यू सर.
सीमा मॅडम करेक्ट. अदिती मॅडम, वही जवळ येऊन द्या कॅमेऱ्याच्या.
आता
अजून
दिसतंय?
द्या, काय नाही होत. करेक्ट. तेजश्री मॅडम, तुमचा कॉन्ग्रुएन्सी दिसत नाही आम्हाला. वर घ्या, पाठीवर घ्या आणि उजवीकडे घ्या. करेक्ट, गुड. So this is simple because we have common side which is hypotenuse and one of the sides of right angle triangle is known to us. Therefore this proof will go through using RHS test of congruence. Okay, good. So this is called AB2. This theorem is AB2. Now the next theorem is going to be easy for all of you because you have learned something in today's lecture. It is concurrency of triangle bisectors. In any triangle, all three internal angle bisectors are concurrent. Okay. So now if we draw any triangle, and if you happen to draw three angle bisectors, one here like this, another here like this, and third here like this, you will find again these three distinct lines pass through a common point. So concurrency of angle bisectors. You take your time to write the complete correct proof. It is, you have experience of writing concurrency proof now, so this should be doable. If you have understood the earlier proof, this should be easy. I will wait for 5 minutes. 8:20, 8:25.
Thank you, Gaurav. There you go.
Okay, Amit sir. Okay, chalo, let us write. Strategy is draw two angle bisectors, get the point of intersection, and show that that point of intersection lies on the third. So let U be angle bisector of angle B. Let V be angle bisector of angle C. Let them intersect at P. So we will get by AB1, if U is angle bisector of B, by AB1 we will get this distance equal to this distance. PD equals PE. If we use the second angle bisector of C, V is angle bisector of C, P lies on that. Therefore, by AB1, if point P lies on angle bisector, then it is equidistant. Therefore, PD is equal to PF. Normally, this is called E and this is called F. Right? So, by AB1, we get PD is equal to PF. Again, by AB1, we get PD is equal to PE. And therefore, these two statements imply PF is equal to PE. That means point P is equidistant from ray B and ray C. Therefore, it must be lying on angle bisector of angle A. This implies by AB2, P lies on angle bisector of angle A. Hence, three angle bisectors are concurrent. Hence, good. Okay, so this point is called in center. And now we have got three segments equal. Of course, they are perpendicular segments. Therefore, we can draw a circle passing through these 3 points, and we will see that it is going to be inscribed circle, but it is going to be tangent to all the three lines. So this is in center. This circle is called in circle, and distance PD, PF. This distance is called in radius. So the moment we get concurrency, we got a circle. Earlier we got circumcircle. Now we got in circle. So this is also a unique point in the plane of ABC, from where you can draw a circle which is going to be tangent to all the three sides. Now we will learn it later. Why is it tangent? Why is it not intersecting? We will find out. But this is another important circle in triangle. No matter how you draw triangle, there will be in circle, there will be in center and in radius. समजलं इथपर्यंत सगळ्यांना? So today basically we have learned PB1, PB2, concurrency of perpendicular bisectors, AB1, AB2, and concurrency of angle bisectors. Good. We will continue discussion like this. On angle bisector, we have to do some more work. But before that, because this diagram is there with us, and now we know what in center is, let us go to, suppose I have a triangle and I have in center I. So what is this point now? I. If we draw angle bisector of A, if we draw angle bisector of B, and if we draw angle bisector of C, these three internal angle bisectors will pass through I. Correct? So let me draw those angle bisectors. It is going to pass through I, and then we know that AD, AE, ID, IE, and IF are congruent. ID is equal to IE is equal to IF is equal to small r. The notation for this is small r. Notation for circumradius, international notation is capital R. When we say capital R, it means circumradius of any triangle. When we say small r, it means in radius of this triangle. Okay. So side opposite to capital A is denoted by small letter. What is the length of B? Yes.
So can you please explain this part again, please, sir? That is in radius, that is ID is equal to IE, means these are the distance. That is in radius, no? These are the.
Yes. ID is equal to IE is equal to IF.
These are the in radius which we are denoting by small r, and the circumradius which are the
capital R. Earlier we have drawn a circle passing through all the three vertices.
That is the perpendicular bisector.
Concurrency of perpendicular bisector.
Bisector, those are denoting by capital R, circumradius.
Yes.
Okay, sir.
That is the notation. I mean, capital R is reserved for circumradius. Small r is reserved for in radius.
And sir, that AI, BI, and CI are the angle bisector.
Yes.
Okay, sir.
X, X, Y, Y, Z, Z. You are the one who is attending from Calcutta?
Sir, I am attending the classes from Kolkata, sir.
Kolkata, okay. Good. Today we have heavy rains in Pune, therefore our attendance has gone down. Okay, so ID, IE and IF in radius we have here, and BC is denoted by small letter A because it is side opposite to capital A, small b opposite to capital B, and small c opposite to capital C. Okay, so let us find out area of ABC. Because now I have got some perpendicular distances and some bases with me. So is area of triangle ABC equal to area of triangle IBC plus area of triangle ICA plus area of triangle IAB? If we add these three triangles, areas of these three triangles, then we get area of triangle ABC. Correct. And is it easy to find area of triangle IBC? Of course, yes. It is BC into ID upon 2. Area of triangle ICA? Yes, easy. CA into IE upon 2 plus AB into IF upon 2. Okay, let us use small letters. BC is small a, ID is R upon 2. CA is small b, IE is R upon 2. AB is small c into R upon 2. We can take R by 2 common, or we will take R common. R common, inside bracket A plus B plus C upon 2. Oh, we made this bracket last lecture. A plus B plus C by 2 is semi-perimeter, which is RS. Delta, area of triangle ABC, is in radius into semi-perimeter. Yes, any questions? Straightforward, simple.
सर आधीच्या याच्यात एक क्वेश्चन आहे सर.
हो, विचारा ना.
आधीच्या याच्यामध्ये जे आपण अँगल परपेंडिक्युलर टाकले ते न टाकता डायरेक्ट पी पासून सी ला जर कनेक्ट केला तर अँगल वरून हे असं काहीतरी प्रूव्ह करू शकतो का सर आपण?
या प्रूफ मध्ये
हा, म्हणजे जे आपण साइडनी प्रूव्ह केलं परपेंडिक्युलर न टाकता डायरेक्ट पीसी कनेक्ट करून द्यायचा आणि मग अँगल ए नी जे ए मध्ये 2 सिमिलर सेम अँगल राहतील, बी मध्ये पण 2 सिमिलर अँगल, आणि मग ते 360 180 असं करू शकतो का सर दुसऱ्या पद्धतीने?
नाही, पहिलं म्हणजे आपल्याला काय प्रूव्ह करायचं ते सांगा आणि मग आपण दुसरी पद्धत आहे का शोधूया. काय प्रूव्ह करायचं?
नाही, तेच प्रूफ तेच करायचं आहे, पण त्याची वेगळी पद्धत होऊ शकते का अँगल वापरून?
कंकरन्सी ऑफ अँगल बायसेक्टर्स प्रूव्ह करायचे.
हा,
आणि नुसते अँगल वापरून एक्स वाय आणि झेड?
हा, एक्स वाय झेड
नाही होणार, होणार नाही.
होईल सर असं वाटतं.
हा, मग एक काम करा तुम्ही, कदाचित नवीन पद्धतीने होऊ शकतं, पण ते असं चालू क्लासमध्ये आपण नाही विचार ना करू शकत. जेव्हा तुम्ही शांतपणे विचार करा, ते लिहून काढा, मला पाठवा, मग मी चेक करतो.
ठीक आहे सर. येस, थँक्यू.
बरं, ठीक आहे. 39 कळलं इथपर्यंत. सो लेट मी गिव्ह यू let me check what we have done last lecture and what we have done today. Find.
सर
हा बोला.
सर मला ते तुम्ही R into S लिहिले ते काय?
तुम्ही मंगळवारच्या लेक्चरला होता.
हो ते.
बरं, मग मंगळवारच्या लेक्चरला जेव्हा पायथन हेरॉन्स फॉर्म्युला आपण प्रूव्ह केला होता तेव्हा a प्लस बी प्लस सी बाय 2 ला आपण काहीतरी म्हणलो होतो.
हा कळलं सर कळलं. ओके सर.
येस. फाइंड इन रेडियस of triangle having sides 13, 14, 15. चला सोपं गणित आहे.
सांगू शकतो सर आन्सर?
दाखवू शकता, सांगू नाही शकत, दाखवू शकता. हा करेक्ट. पटणे मॅडम करेक्ट.
सर
अमित सर नॉट करेक्ट.
सर
हा एक मिनिट बघतोय एकेकाचं. रश्मी मॅडम करेक्ट. अर्पिता मॅडम करेक्ट. हा अमित सर करेक्ट. वैशाली मॅडम नोटबुक जवळ घ्या, अजून चुकलं. अरे 2 आहेत वैशाली. वैशाली मॅडम करेक्ट. ज्योती मॅडम स्मॉल r इज इक्वल टू एवढं लिहून मला दाखवायचंय, चुकलं. आता कोण दाखवतोय? नेत्रा
सर?
मॅडम परपेंडिक्युलर झाली वही तुमची. हा कोण दाखवतोय? हिना मॅडम.
सर
हा क्लोज घ्या, अजून क्लोज. थोडा दिसत नाही. नाही, चुकलं. ओके. सीमा मॅडम करेक्ट. प्रीती मॅडम करेक्ट. नेत्रा मॅडम करेक्ट. सीमा मॅडम करेक्ट बोललो मी ऑलरेडी. शुभांगी मॅडम करेक्ट. मधुरा मॅडम करेक्ट. सेकंड स्क्रीन दाबा. हा सेकंड स्क्रीन. रुद्रेश सर तुमचा एरिया दिसतोय, मला हे नाही दिसत, रेडियस नाही दिसत. हा करेक्ट. नीना मॅडम 105 अपॉन समथिंग ना रेडियस, नॉट करेक्ट. चैतन्य करेक्ट. आणि कोणी इकडे चिन्मय गुरव करेक्ट. श्रीकर पुरंदरे करेक्ट. आलाय सगळ्यांचा. रेडियस इज 4 बिकॉज एस वॉज नोन टू अस 21. Area is 84. Area is 84, which is equal to R into 21. Therefore, R is equal to 4. In radius is 4. Good. Sure. Now let me show you one more interesting thing in this configuration. मधुरा मॅडम तुम्हाला विचारायचं काही? Okay, what we have done here is we have drawn three internal angle bisectors. Here we have drawn three internal angle bisectors: XX, YY, ZZ. However, if I have a triangle and if I extend the arms, suppose this is triangle ABC, correct? And we have drawn internal angle bisector of B and C earlier there and shown that I is a in center and it is equidistant from the sides. But now I can see if I extend side AB and side AC, I can see one more angle here, which is exterior angle of triangle ABC. If I consider exterior angle at B and exterior angle at C, then I can draw their angle bisectors. Let U be angle bisector of CBM. External angle, not CBA, but CBM. Yes, you can draw. Also, you can draw external angle bisector of BCN. Yes, we can draw external angle bisector. Let V be external angle bisector of BCN. U be external angle bisector of CBM. Let them intersect at P. Then what will happen? P is on angle bisector of CBM, correct? Therefore, by AB1, what must happen is, if I drop perpendicular on ray BC, whatever perpendicular I will get, and if I draw perpendicular on ray BM, whatever I will get, these two guys are supposed to be equal by AB1. So let me give some notation. Let us call this as D1 and this as F1. And let me eventually, I'm going to call this, instead of P, I'm going to call it as I1. Inside it was I. So now first time I am doing the work opposite to A. So I call it as I1. So by if I1 is a point of intersection of external angle bisector of B and external angle bisector of C. Therefore, by AB1, I1 is equidistant from ray BC and ray BM. I1 D1 is equal to I1 F1. Correct? Oh, again, V. I1 lies on V. And V is a external angle bisector of CB and CN. Therefore, I1 must be equidistant from CB and CN, which means I1 D1 is equal to I1 E1. This is by AB1. This is by AB1. Oh, similar situation. I1 D1 is equal to I1 F1. I1 D1 is equal to I1 E1. This implies I1 F1 is equal to I1 E1. This is equal to this. because both of them were equal to this. And hence, I1 lies on by AB2. I1 lies on angle bisector of A, internal angle bisector of A. This implies I1 lies on internal angle bisector of angle A. So now this is the concurrency of two external angle bisectors and one internal angle bisector. This is R. Okay. So now the moment we get concurrency, we have a circle with us. I1, D1. If we take radius, then we will have a circle. And this is circle opposite to capital A. First circle. And this circle is not inside the triangle, it is outside the triangle, but it is touching all the three sides, lanes, BC, AB, and AC. This circle is called X circle. I1 is called X center. And this I1D, I1E, I1D1, I1F1, and I1E1, they are denoted by radius R1 and called X radius. Understood? So we have exactly similar situation. Earlier it was inside, now it is outside, and if it is opposite to A, there will be two more circles, one opposite to B, another circle opposite to C. So as far as angle bisectors are concerned, there will be four circles, one inside triangle and three outside triangles, and all those circles are going to have several properties which we will discuss in next lecture, but this is very, very interesting. Any doubt, difficulty, question?
Sir, बोलू का?
बोलो ना.
Sir, how we can say I1 lies on internal angle bisector?
I1 lies on an internal angle bisector because I1 is equidistant from AC and AB. I1 is equidistant from ray AC and ray B, and that is internal angle. I1 is in the interior angle of triangle ABC, therefore it must be internal angle bisector. नाही समजत?
नाही सर समजलं RHS नी आपण ते दोन कॉन्ग्रुएंट हे करून
आता कॉन्ग्रुएन्सी वापरून आपण AB1 AB2 तयार केले, म्हणजे आपण ऍडव्हान्स टूल तयार केलं आपल्याकडे. सो नाउ वी आर युजिंग AB1 AB2, वी आर नॉट गोइंग बॅक टू कॉन्ग्रुएन्सी. Any questions before we end? We will stop at this point today and continue our discussion in the next lecture. There will be two more lectures next week. I will complete some theory in the first and we will solve few problems in the last lecture. Next Thursday, we will solve problems.
Sir, so for first two lines, we are applying AB1 and that I1 lies on internal angle bisector of angle A. It is by AB2.
By AB2, yes.
Okay.
Correct. Okay, stopping share, ending meeting. Thank you.
Sir, मी
बोला.
अपार्ट फ्रॉम ह्यापेक्षा वेगळं काही विचारू शकते का? आज माझ्या मुलाने मला हा प्रश्न विचारलाय.
हो
त्यामुळे
विचारा
हा
विचारा. मला येत असेल तर सांगेल.
नाही सर, इन्फिनिटी प्लस इन्फिनिटी मी त्याला सांगू शकले. इन्फिनिटी आहे आन्सर. बट
किती
ही इज
वर्षाचा आहे?
आस्किंग
किती
सातवीला आहे.
वर्ष वय?
सातवीला आहे.
त्याला सांगा 4 वर्ष थांब जरा.
नाही, तो तयारी करतोय सर आणि तो
बरोबर.
विचारतोय मला की इन्फिनिटी मायनस इन्फिनिटी काय होतं, कारण की मला इन्फिनिटी प्लस इन्फिनिटीचा आन्सर देता आलं आणि तो सॅटिस्फाईड पण झाला त्याच्याबद्दल. पण इन्फिनिटी मायनस इन्फिनिटी मला थोडं नाही, म्हणजे नाही सांगता आलं.
त्याचा आन्सर मी सांगतो, पण एवढ्या लहान मुलांना हे करायचं नाहीये, हे पण सांगतो. त्याचा आन्सर आहे इनडिटर्मिनेंट.
इनडिटर्मिनेंट. ओके. मला काहीतरी तो म्हणत होता 0 प्लस 0 मायनस काहीतरी कॉन्सेप्ट आहे आणि तो मला समजायचा प्रयत्न करतोय, पण मला ते नाही लक्षात आलं. म्हणून तुम्हाला विचारतेय की काय, फक्त तेवढं एकच सांगू का त्याला?
इनडिटर्मिनेंट एवढं सांगा.
ओके, थँक्यू सर.
Thank you, sir.
Okay, ending the meeting. See you on next Tuesday.
Thank you.
sir.
Thank you, sir.